In this set of videos, first of all, we are going to understand what is a binary number, and after that one, we will understand how a binary number can be converted into a decimal number. So we will start with the non-fractional binary numbers, conversion of non-fractional binary number into decimal number. So primarily, we know the binary number system is a string of it is a string of two digits, only two digits, 0 and 1. And these two digits are called binary digits. These two are called binary digits. That means binary digits are only two in number, 0 and 1. So these two are sometimes in short called bits, binary digits. Okay, so generally these are used in computer. So we are to know the conversion of binary numbers into decimal numbers. So in the beginning, we should understand two important facts related to binary numbers. Firstly, these numbers, these set of numbers are also very similar to the decimal numbers in the context of positional value. As for example, if you write here in decimal system, if you write 23 in decimal system, then this 2 had a sense of 2 into 10, that means 20. But if it would have been written in this way, 32, then the same digit 2 has its positional value only 2 into 1, and the same happening is there for the binary numbers. They are also having positional values. So if I write 1101, mind it, these numbers are written only, binary numbers are written only with the help of bits, that means binary digits, that means 0 and 1 only. So I have written here 11001, and if this is a binary number, then these three ones are having different values. Okay, we will understand just in a minute. So these are having their positional values different. Now the second most important fact related to this one is any digit, any digit that is in the leftmost part of writing is if 0, then it has no significant value. As an example, if I say 0 1 0 1 1 0, if this is a binary number, then this particular zero has no significance. So if in place of this one, it would have been only written as this, then these two would have been the same number. They would have been representing the same number. So mind it, binary numbers are having only two digits, which are called bits, 0 and 1. So all the required numbers will be written with the help of only these two digits. And one very important fact is this: the number, the digit 0 that is written in the leftmost part has no its significance, and all the digits are having their positional value. Now, come on to understand the conversion of binary number into decimal number. Suppose that a number is given to us and we are to write down in the decimal system. Decimal system is what? We are to write any number using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 10 digits in decimal system, and using that one we write any number. And if we are to convert a binary number into decimal number, then we begin with the non-fractional fractional binary numbers converted. Okay, into decimal number, into decimal system. So in this context, we should have any algorithm. Algorithm, that means a set of facts. Using that one, we can understand, we can draw the result. Okay, so we have an algorithm like this, very similar to the decimal system. As for example, if in a decimal system we write any number like this 521, then we know that these numbers are having their place values, and so why they are written as this number add this number add 1 into 10 to the power 0, this number is written as 2 into 10 to the power 1, and this number 5 is written as 5 into 2 to the power 1, sorry, 5 into 2 to the power 10. Rather, I should write this way in this way, 5 into 10 to the power 0, 1, 2, plus 2 into 10 to the power 0, 1, plus 1 into 10 to the power 0, and later we add to them to get the number. Having the same algorithm in binary number, we can convert any non-fractional binary number into decimal number. Multiply the digit at the rightmost place by 2 to the power 0, just we did here by multiplying 10 to the power 0, and multiply the digit just right to the just right to it by 2 to the power 1. No, rather just left to it by 2 to the power 1, and so on. Finally add the numbers. Finally add the numbers to get the value in decimal system. Just we did here. The rightmost digit is multiplied by 10 to the power 0, and we will multiply by 2 to the power 0. Here, the leftmost, just left of that number, 1, that is 2, is to be multiplied by 10 to the power 1, and in the binary number we will multiply by 2 to the power 1. Similarly, 2 to the power 2, 2 to the power 3, and so on, we will multiply them and we will add them to get the value of the number in decimal system. In this context, we are taking some examples. Suppose that we are to convert the following non-fractional binary numbers into decimal numbers. So the first number which I took is this one. This is written in the binary format, and we want to convert it into decimal system. In this context, first of all, we will multiply to this one by 2 to the power 0, 1, 2, 3, and 4. So 0, 1, 2, 3, and 4. Okay, so this 0 is to be multiplied by 2 to the power 3, plus this 1 is to be multiplied by 2 to the power 2. Similarly, this 1 is to be multiplied by 2 to the power 1, and to this we will multiply 2 to the power by 2 to the power 0. So clearly it will be equal to 16, and this will be equal to 0, this will be equal to 4, this will be equal to 2, and this will be equal to only 1. 2 to the power 0 is equal to 1, so it will be 1 into 1. And so we got the result 2023, and this is the answer of this question. Again, so we can write down that this is equal to 11011 in the binary number is equivalent to the number in the decimal system, that is 23. So this conversion is necessary to convert the binary numbers into decimal numbers. Later on we will understand how a decimal number can be converted into binary numbers. Now another example. Take the another example here on the next sheet. So in the next sheet we took the number, and now we want to know the conversion of 110, the second one, 1101, a number in binary system into decimal system. Obviously we will write in the same manner. This will be multiplied by 2 to the power 0, this will be multiplied by 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the that means it will be multiplied by 2 to the power 6. Again we know that when we will multiply 1, then it will be by 2 to the power 5, and 0 will be multiplied by 2 to the power 4, but we know that 0 if it is multiplied to any number it gives 0 as a result. So write simply 0, and to this one we will multiply by 2 to the power 3, because 0 1 2 3, so 2 to the power 3, and this one by by 2 to the power 2. Similarly, this 0 will give the answer 0. So write simply 0. And this one is multiplied by 2 to the power 0. That means by 1. So simply write 1. So the result of this one is 2 to the 4, 4 to the 8, 16, 32, 64. So it will be 64. And this will be 32. This will be 8 plus 4 plus 1, and this is the answer of this question. 6 34 32 plus 8 is equal to 40 40 104 108 109. So the answer is 109. So in the decimal system the result is 109. Okay, again we should check it. 64 rightly, this is equal to 32 8 4 1. So correctly 40 60 100 104 108 109. So this is equal to 110. Again to the third, for the third one, again we can do the same activity, rather it is equal to 0. So write here 0 1 1 2, and so easily you can convert this one into into decimal system in this way. 1 will be multiplied by 0 1 2 3 4, 2 to the power 4. Clearly these two will give us 0, so do not need to write there. 1 into, for this second one we can write 1 into 2 to the power 1, and we know that this one is to be multiplied by 2 to the power 0, that means 1. So simply write 1. So we have now 16 plus 2 plus 1, and so the answer is 19. So in the decimal system it is equivalent to 19, and I hope you could understand. If you could not, go through the video again to understand that one. Okay, and in the next video we will discuss about the conversion of fraction part of binary number into decimal system. Okay. Link of the PDF is in the description box, so you go through to have the link and get the PDF of this lecture. Okay.